This video is for section 11.1. Our objectives in this section are to find particular terms of a sequence from the general term, use factorial notation, and use summation notation. So we're going to start by defining what a sequence is. Sequences are ordered lists of numbers. So ordered means that there is an order that they are in that makes sense. So there's some type of pattern. They're not just randomly kind of thrown out there, but there's a pattern to how the numbers are arranged. So it's a list of numbers with an order to it. Each number in the sequence is called a term. A sequence can be finite or infinite. So it could just be kind of a list of numbers and then there's an end to it, or it could be a sequence that goes on forever, and obviously we don't have all of the numbers if it goes on forever, but we have some of them, enough to see what the pattern is. So a sequence can be finite or infinite. We have notation for sequences that involves using the letter A. So we have A stands for the term, and then we put a subscript which tells us the term number or the position of the term in the sequence. So A sub 1 would be the first term. A sub 2 would be the second term. And then we could continue. A sub 3 would be the third term, etc. We also have what's called the general term, which is A sub n. And the general term is generally looks like a formula that you plug numbers into to get the sequence values. And we'll see an example of that in a second. So one example of a sequence that is somewhat well known in math is the Fibonacci sequence. For the Fibonacci sequence, the first term, A sub 1, is 1. And the second term, A sub 2, is also 1. To get terms after that, you add the two previous terms to get the next term. So the third term is going to be 1 plus 1, which is 2. The fourth term would be 2 plus 1, which is 3. The fifth term would be 5, 3 plus 2. And the sixth term would be 3 plus 5, which is 8. And then the next term would be 13. I could keep going. So this would be an infinite sequence because I can just keep adding the previous two terms to get the next term. So next we're going to look at example 1. It says to write the first 4 terms of the sequence whose nth term or general term is given. And these are going to be general terms that look like formulas. So what I'm going to do here is I'm going to plug in 1 for n gives me the first term, plugging in 2 gives me the second, plugging in 3 gives me the third, and plugging in 4 gives me the fourth term. So I'm going to plug in all those numbers for n. So A sub 1 is going to be 3 times 1 plus 4. 3 plus 4 is 7. A sub 2, I would plug in 2 for n. That's going to give me 6 plus 4, which is 10. For A sub 3, I would plug in 3 for n. 9 plus 4 is 13. And for A sub 4, I would plug in 4 for n. And that's 12 plus 4, which is 16. Now the way that this is going to be in the homework is each one of these is going to be a separate box for you to fill in. So it'll open up a box for a sub 1. You would type in the result. Once you get that correct, then it'll open up a box for a sub 2. Once you get that correct, it'll open up the next box for a sub 3. So each of these will be a separate box for you to fill in. Now we're going to look at part B, which is a general term that's a little bit more complicated, but it's the same process. We're going to plug in 1, 2, 3, and 4 to get each of these terms. So I'm going to start with 1. So in this formula, there are 2 places to plug in n. One as an exponent in the numerator, the second as an exponent in the denominator. So -1 to the first is -1. 3 to the first is 3. 3 minus 1 is 2, so my answer here would be -1/2. I'm going to plug in 2. Now, -1 squared is +1 because it's -1 times -1. And 9 minus 1 is 8, so this is going to be 1/8. Next, I'm going to plug in 3. -1 to the third is -1. And 27 minus 1 is 26. Then I'm going to plug in 4. -1 to the fourth is +1. And so that's going to be +1/80. So the effect of having this -1 to the n power in the general form, what it's going to do is it's going to cause these signs to flip. So it's going to go from negative to positive to negative to positive. If I did a sub 5, that would be back to negative. So next you should look at checkpoint problem number 1. Do these in your notes, check your answer, and then move on with the rest of the video. Next thing that we're going to talk about in this video is factorial notation. Factorial notation looks like an exclamation point. So if we have some number with an exclamation point after it, what you do is you multiply that number by every number all the way down to 1. So n minus 1 times n minus 2 all the way down to 3 times 2 times 1. Multiplying by 1 obviously is not necessary because you get the same thing, so you really only have to go through 2, but we always say to go down to 1. So I'll write this out as instructions. Multiply by every number down to 1. And we have a special couple of cases that we use sometimes just to make the math work out well. If we have 0 factorial, we say that that's equal to 1. That's kind of just a math thing. It doesn't really make too much sense, but it's needed to have calculations come out nicely. And then 1 factorial, well, there's no numbers between 1 and 1, so we say that is also 1. So both of these are 1. 2 factorial would be 2 times 1, which is 2, and then you can kind of go up from there. So that's what factorial notation is. You'll see an exclamation point button on your calculator. So on this calculator, it's under the function menu right here. But for the ones that we're going to do in this class, they're going to be pretty small numbers. So you could also just multiply all the numbers together, like 4 times 3 times 2 times 1. If you were doing something like 20 factorial, that would take a long time to type out, and so it'd be easier just to use the button. But you probably won't see anything that big in this class. So we're going to look at example 2. It says to write the first 4 terms of the sequence whose nth term is 2 to the n over n minus 1 factorial. So we're going to start with the first, a sub 1. We plug in 1 for n into both places. So 2 to the first is 2. And 1 minus 1 is 0. So here we're going to use that rule that 0 factorial is assumed to be 1. So that'll give us an answer of 2 over 1, which is equal to 2. Now this is one of those situations where MyMathLab is going to want things completely simplified. So if you type 2 over 1 in, it's going to mark it wrong because it's not completely simplified. You would have to just type 2. Next I'm going to plug in 2. So 2 squared is 4. And 2 minus 1 is 1. So 4 over 1 factorial. And like we said earlier, 1 factorial is just 1. 4 over 1 is equal to 4. For a sub 3, plug in 3 for n, plug in 3 for n. 2 to the third is 8. 3 minus 1 is 2. And 2 factorial would be 2 times 1. So 2 times 1 is 2, and 8 divided by 2 is 4. So this is kind of a weird thing because third term is the same as the second term. So the pattern in these is not always like super predictable or obvious. Lastly, we want to do the fourth term here. So plug in 4 for n and 4 for n. 2 to the fourth is 16. And 4 minus 1 is 3. So this is going to be 16 over 3 times 2 times 1. 3 times 2 times 1 is 6. Now, if I enter 16 over 6, it's going to be marked wrong because that fraction is not simplified. So you need to simplify any fractions. 16 over 6 is 2 times 8 over 2 times 3. So I can simplify that to 8 over 3. So that would be the fourth term. So next you should do checkpoint problem number 2. Do this in your notes, check your answer, and then move on to the homework.